Well, that's a bit of an oddity. This is a Thomson 32HE8022, which somebody had left for dead at the local recycling centre, and when I brought it home and just plugged it in as it was, it would not go out of standby. No matter what you did, it wouldn't respond to the buttons, no nothing. It did show a good standby LED, so I knew that we had standby power to the mainboard, and I also measured that we had fine standby voltage by just taking it apart and having a little probe around. Then I tried to just provide 3.3 volts at the power supply turn-on pin, which was nicely labelled at the mainboard, and lo and behold, the power supply actually turned on and gave fine 8-bit voltages, so I was pretty certain that the issue was not with the power supply. So what I then did was try to just force the pin on the mainboard, which controls the power supply turn on, high, and that wouldn't work. It seems as if the transistor responsible for turning the power supply on has shorted out or something, because I can actually turn this TV on by just disconnecting the pin from the mainboard and forcing it high. So let's have a look at how that works. So here's a look at my hacker little arrangement. So I've got a lead going to my power supply here, which I've just connected to a wire that I've pulled out of a plug, and this is one that is labelled the power supply on. So it's no longer connected to the mainboard, only the power supply of the TV and my bench power supply. And if we plug the TV in and turn the power supply on, and we can see that it starts drawing a quite considerable amount of power, about 100 watts right now, and it's humming away nicely. The backlight is turned on, and if we have a look at the screen and reconnect my ground, we can see that we get a pretty okay picture. And this is just the analog TV noise, and if we open up a menu, everything seems to be working just fine. We can navigate around, and everything just seems to be in perfect working order. It does run a bit laggy sometimes. I'm not certain why that would be, but this TV does turn on when you try to turn it on, and it actually does disable the mainboard as well. If we press the power button, it will just blank the screen and fail to turn the power supply off, entering standby mode, and it won't power on until you've power cycled the power supply. So there really is something going on with the power supply enable part of the mainboard, so we're going to have a bit of a closer look at that. Alright, so I've now probed around this motherboard quite thoroughly, and I have located the issue basically beyond the shadow of a doubt, and that would be this standby processor, which is an off-brand thing. It's labelled WT6702F. It's a programmable microcontroller with integrated memory, so replacing it is pretty much out of the question unless you have a donor board, and there's a fair risk that any other board is going to have a similar problem. So the way I went around diagnosing this was by initially tracing out where the power on signal was coming from, and it was coming through quite convoluted transistor arrangement there, being fed by straight from a pin on this device. I then proceeded to probe around to figure out where the button control input was coming from, and it goes partially straight into this big processor, but it doesn't seem to receive any real supply when the TV is in standby. But it was also going to a pin on this processor. So what I then proceeded to do was just jab around, try shorting a few pins, checking if the states changed on the pins when you pressed the buttons, and what changed when the TV was on, and so forth, and it didn't really yield any fruit, except for the fact that one of these pins changed when you pressed the power button, because it was connected straight to the power button. So what I then proceeded to do in order to verify that the issue was in that area, and I got a bit lucky, was I just heated up this entire area of the board, and lo and behold, the TV turned on and turned off quite fine for about 2 minutes, and then it got stuck in either on or off. So that pretty much narrowed down the issue to that area of the board. And what I then proceeded to do was to heat up the entire area of the board again quite hot, just using a hot air gun set to 100 degrees Celsius. I put some thermal compound on the processor and just jabbed the heatsink onto it to cool it down, while the remaining surrounding circuitry remained hot. And the issue came straight back. The TV would not turn on. I removed the heatsink, let it soak up some more heat. The TV worked perfectly. So there's an issue inside of that chip, and we're basically screwed. However, it is possible to basically operate the set if I just short the power supply on output to the supply rail of this processor, just locking it permanently high. The downside of doing this is that the standby power consumption of the TV becomes about 12 watts, which isn't very energy efficient. It'll become a little space heater for you. But it does allow you to use the TV, and you can turn the rest of the main board on and off using the power switch and probably the remote, which I don't have. So at this stage I'm not really certain what other way to go about it. One option would be to just design a circuit to basically mimic the functionality of this chip, but that would be a bit of a bother because the power button isn't just a digital on-off, it's actually an analog thing which pulls the pin on that chip down to 0.6 volts, and all the other buttons on the control panel of the TV put it to different analog levels, so it would be a real issue to filter all that out using some analog circuit. It's obviously going into an ADC on the processor. Sadly, there isn't any datasheet available for the processor. The best I could find was a datasheet for some Chinese TV module which used it for a similar application, and I was able to figure some stuff out, but it had all the pin labels incorrect and so forth, so it didn't yield too much fruit. But for the time being, I think I'm just going to go the ugly route and just bridge the power supply to always be on and let it run for as long as it runs, warming the room up in the process. And just because I know you want to see it, has how the TV behaves. So it's now connected up to this power outlet, just in its normal configuration. The board is cold, it's drawing about what's in standby, and if we press the power switch, nothing happens. And if I just take a hot air gun, give it a thorough heating, give it a reset, and then power it back on, you can see the power spikes up to 15 watts for a while. It'll now turn off again. Oh no, it went into the on mode because it was on when I turned it off last. And now the power button will work absolutely fine as long as the chip is hot. And if I grab my heatsink and just turn the TV off, it will not turn off the standby power now. And if we reset the entire set again, it will not power on. It's stuck in standby. So I'd wager that's a pretty thorough diagnosis of that chip being done for. And there we go, there's the fix in place. I've shorted together the top right pin with the pin that's second closest to the bottom on the right side, and this will just force the power supply to basically turn on at all times and never ever enter standby mode. I also made the effort to replace a couple of dodgy looking caps right above the processor heatsink. The new ones I mounted on the other side of the board since they otherwise wouldn't fit underneath the EMI shield. And if we plug the TV in now, it'll turn on just fine and turn off when you press the power button, at the cost of drawing about 12 watts in standby. But it does seem to be able to both turn off and turn back on when you need it to, so at least the TV has working functionality now. So let's see how the world's least eco-friendly TV looks. And the answer is like analog TV noise, and that sadly is a bit as much as we're gonna get out of it right now, because I don't have a remote for it, and it's one of those stupid designs where you need to have a remote in order to switch sources, and indeed in order to do anything, say for adjust the volume and change the analog TV channel. So, I guess we'll have to call it for this video. At least the TV is powering on now, and my endeavours to find a remote for it can begin. So, thank you for watching. I hope you are a dirty electricity conglomerate who'd like to buy this TV, because it's going to put out a lot of greenhouse gases in its lifetime. Cheerio.